So we're going to be talking about an introduction to vectors. Chapter 8 is all on vectors, right? So a vector is important in the fact that it has two things, right? Vector has a magnitude, a length, and a direction, right? And so a lot of times we think of like vectors to be like the wind, right? So, it says it's going 40 miles per hour due east, or, 10 miles an hour northwest, or whatever. So it has two different things. It's measuring the speed, the wind speed, and its direction, right? Those are called vectors. Now, there's also something called a scalar, and that's when it's just one thing, right? A scalar is just one number. And so we think of like, my car is going 28 miles an hour, right? That's just the speed, right? I'm not talking about direction, so that's a scalar number, right? I could give it a direction, but I'm not. So what we're going to do in example 1 here is we're going to identify the difference between scalar and vector number quantities, right? So letter A, a boat is traveling 15 miles per hour. You'll notice it doesn't have a direction, right? So this is just a scalar value, okay? Letter B says a hiker walking 25 paces due west. Now, due west all of a sudden now makes this a vector because we're talking about a direction. And then finally, last one, a person's weight on a bathroom scale. Okay, could be thought of two different ways. I would call this a scalar, but if you were thinking that the direction is going straight down because of gravity, you could technically give it that direction, and you could call it a vector. So if you wanted to say that, you could, but I would say scalar is probably a better way to represent that. Okay, here's a couple problems that you can try on your own. Now, how are vectors measured? Okay, well, vectors have what are called an initial point and a terminal point. So over here, I have an initial point A and a terminal point B where it ends. Okay, so this is going to be vector A, right? This is vector A, starts at A, ends at B, right? Now, all vectors have a direction, and so there's a lot of different ways that you can do it. Now, if you wanted to use standard position, that's basically kind of how we did the unit circle. It starts here, okay, starting with X and starts moving up towards Y, kind of like, remember this was 0 degrees and I moved up towards 90 degrees and so on and so forth, right? That's our standard position, and that's generally how we're going to get a lot of our values. Now, to find our to find our magnitude, we're going to have to use some sort of a scale or something like that. And so in this case, it says, now this is different because this is coming from a book, not really from here, but if I measured this out, it would say that 5 feet per second is really equal to 1 centimeter. Okay, so if you're drawing in your notes, you want to make it a certain length. So you're probably going to want like a ruler or something, or a meter stick or something like that, if you were going to do that for sure. Now, the magnitude is denoted by this. It looks like absolute value, but it's actually not. That is the magnitude. That is like how fast or something is moving. So in this case, feet per second is how fast it's moving, right? And so it's denoted as it looks like absolute value of A, right? Now, there's another way to give direction, and that's called quadrant bearing, okay? And so we remember our quadrants, and in our case, we talk about north, east, south, and west, right? And so it would have different quadrants based on this, okay? They use this kind of goofy Greek letter phi. We don't really need to use that. But if they were going to say that we're going 35 degrees east of south, we'd write it like this: south 35 degrees towards the east. And so this would be 35 degrees right here. That's what our phi is. 35 degrees. Okay? That's 35 degrees right there. So that's how we would write south 35 degrees east, right? The other way to do it is called true bearing. Okay, true bearing, and this is how pilots use direction when they're flying. And they would say that north is considered 0 degrees. And then I move in a clockwise position all the way back up to, I guess this would be 359 degrees. You have to forgive my pen today. 359 degrees, and then back to 0, right? And so that's true bearing. And so we can give any measure between 0 and 360. Okay, so what we're going to do is we're actually going to draw this. So what I want you to do is I want you to draw 3 coordinate planes, right? We're going to do that. And I'm actually going to use, it's not going to let me use a compass on here, I guess. But what I'm going to do is I'm going to, we're going to have to get really good at checking out these kind of like dotted lines right here, right? Okay, we're going to use this, and it's going to use our measurements, right? And so I'm going to let each one of these tick marks represent something, okay? So I want to draw, okay, I want to draw 20 feet per second at a bearing of 30 degrees. And this is using true bearing, right? So what it means is right here at north, that's our 0 degrees. And so I have to move 30 degrees. Now, I can't use a protractor on here to show you, but what I'm going to do is I am going to, we know that if this is 45 degrees, 30 degrees is going to be a little bit less. And I'm going to draw it just like this, okay? And I'm going to stop, and I'm going to count my tick marks, and then I'm going to write my scale, right? So this right here is 30 degrees, right? And let's see, we count 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks, and I want it to be 20, right? So I'm going to say, actually, I could probably maybe make that to be 10 tick marks right here. Okay, I'll draw it just a little bit longer. There's 10 right there. And so I'm going to say, I'm going to count those as 1 dash equals 2, so it would be 2 feet per second. There's 10 dashes, so I'm moving 20 feet per second. So that's how I'm going to draw it. Now for you, you might actually be able to use a ruler and measure out, and instead of dashes, you can actually use like inches. You could say 1 inch equals 2 feet per second, or you actually, it would probably be like 1 inch equals 10 feet per second, be 2 inches long, or whatever, okay? So that's how we can do letter A. Letter B, okay? Now I'm going 140 degrees towards the horizontal. So that's like when we started with the unit circle, 0 degrees right here. And I want to go 140 degrees. Okay, so this is 90, and this is 180. So we know it's going to be between these two right here, right? And so I'm going to use my dotted line again. Okay, 140 is going to be like right, well, think about that's 135. It's going to be a little bit less than this, right? And I want it to be 75. So I'll make it be 5 dashes right there. Okay? And so I would label, first off, I'd label that this is, okay, right here is 140 degrees, right? And I'd say 1 dash is equal to, if there's 5 dashes here, it would be equal to, if I divide that by 5, it would be 15 pounds of force. Okay, so 1 dash is 15 pounds. I have 5 dashes, and so that would be 75 pounds. Okay, that's how I can do it. You could do the same, letting, again, 1 inch be 15 pounds of pressure in your notes. Finally, the last one, letter C, 30 miles per hour at a bearing of south 60 degrees west. So if I think about it, here's south right there, and here's west, and I'm starting at south and I'm going 60 degrees. Okay, so again, I know that straight this way would be 45, so 60 would be less than, it would be like right about there. And I want it to be 30, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, make it 10, right there, 10 dash marks, right? And so we know that this is right here, 60 degrees, right? So we start at south, then we go 60 degrees towards the west, right? And we would say that 1 dash is equal to 3 miles per hour. So then since there's 10 dashes, it's going to be 30 miles per hour. Again, you could do kind of the same thing. 1 inch is 10 miles per hour. Yours would be 3 inches long, whatever. Okay. Now this one I'm not going to check to see if you understand it, just because it'd be super hard for me to draw it on there, or for have you draw it on the video. But essentially, you can do kind of the same thing here. All right. Now we're going to talk about what's true with some vectors. Now, okay, parallel vectors are going to be in the same direction. So you'll notice A and B are parallel, right? They go in the same direction. So does C, right? A, B, and C are all parallel. They go in the same direction. Now, equivalent vectors means that they have the same magnitude and direction. Now, you'll notice that A and B are not equivalent because B is actually has a bigger magnitude. It's longer, right? But C is the same in length. So A and C are going to be considered equivalent vectors. Okay, same length, same direction. Opposite vectors have the same length, A and E, but they're in the opposite direction. Okay, they're in the opposite direction, and so we'd actually say that their magnitudes are negative of each other, right? They're same direction, but their magnitudes are opposites. So what we can do is we can actually find when we add two vectors that something happens. When we add two vectors, it's called the resultant vector. Okay, and so what I want you to do, or what you can do is I want you to figure out which one of these you like the most. Okay, there's one called the triangular method, and back when I was in school, this was the only method that we used to use, was the triangular method. It's called tip to tail. And essentially what you do is you draw vector A, and then right from the end of vector A, its terminal point, you draw as the initial point for B. And then what you do is you basically connect the starting point to the ending point, and that's going to be your resultant vector, right? The other method is one that I learned when I started teaching PreCalc, and it's called the parallelogram method. And basically you let A and B both start at the same initial point. Okay, you look at their directions, and then what you do is you basically create a parallelogram. So you take this down here is going to be like another little ghosty vector B, and this is a ghosty vector A, okay? And then where the two meet is our resultant vector, okay? Now some people like this way more, and that's cool. Whatever you want to do, okay? But for me personally, I think the tip to tail method is the best way to do it. Now, it says a group in an orienteering competition, which is basically like land surveying or whatever, okay, Tia is walking 50 degrees, north 50 degrees east, meaning she's starting at north 50 degrees towards the east for 120 feet, and then she walks 80 feet due east. How far and in what quadrant bearing is Tia from her starting position, okay? So what I want everyone to do is I want you to draw a coordinate plane, okay, right here. All right, now, we know that this is north and this is east, right? And that's what's going to be important for our problem. Now, we're going to use our dash marks. We're going to give it a magnitude and an angle, right? And so what's going to happen is I'm going to look at this and I'm going to say, okay, so if this is 45 degrees right in the middle, 50 degrees this way is going to look kind of just a little bit less like this. And now I want it to be 120 feet. So what I'm going to do, I notice that both of them are multiples of 40. I'm going to, let's see, maybe do, well, I could probably do each one being like 10 feet. So this would have to have 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right there. Okay, so that's 12. Perfect, that's 12. And this is going to be our 50 degrees right there. Okay, so that's her initial walk. Then the next one, okay, she's going to walk 80 feet due east. So starting here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Right there, okay? And due east is just 0 degrees towards the east. Okay, so this is her first, and then second direction. And so what we're going to do is we're going to find out where she actually is, right? And so that means I start here and I go tip to tail, okay? All right, so you'll notice that this angle right here, okay, if this was 50 degrees, I'll do this in different color. If this is 50 degrees, right? This originally would be 40 degrees, and it's not exactly half, so we're going to kind of guesstimate a little bit, okay? And we're going to guesstimate that this is going to be about 30 degrees, right, from east, okay? And we're going to count the number of tick dashes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So she's going to be going 190 feet. And we're going to say, we can write it back in true bearing where they gave it to us, which was north. And then we want it to be 90 degrees here. So it would be north 60 degrees east. Okay? So basically she lost 10 degrees. Okay, so that would be right there. Just using quick estimation, you could maybe use a protractor and a ruler and get something similar to it when you're doing this problem as well. Okay, so we're going to say that she's actually 190 feet north 60 degrees of east, or east 60 degrees of north. Okay, depending on how you want to say that. Okay, so here's a guided practice problem. You can try these. I would say let's look at letter C. Okay, now we can actually have what's called a zero vector, or sometimes they call it the null vector. And that's when you're adding one or two vectors with the same direction, but opposite magnitudes. So when we add opposite vectors, so in our case, A and negative A, it results in nothing. And so if you think about it like this, if I go in this direction, right here, let's say 30 miles per hour, then I turn around and go 30 miles per hour in the opposite direction, you'll notice where I end up is actually where I started, right? It's like driving your car, 20 feet forward and then backwards 20 feet. You start back where you began, all right? So that's called the zero vector. Another thing that's important to know is multiplying vectors by some scalar value, okay? So if I have a vector v and I multiply it by some scalar value k, then it has a magnitude of k times v, right? And so if k is positive, okay, so let's say I have, this is my vector v, and I'm going to multiply it by k equaling 3. That means I'm going to take this v, and I'm going to have 1, 2, 3 of them, okay? So you'll notice that this is v and this is v, and it's going in the same direction. It's just now 3v in length, right? But what if I have vector v right here, and I multiply it by k being negative 2? Now what's happening is I'm taking v, I have 2 of them in the opposite direction. So that's negative v and that's negative v. So now I have negative 2v. It's going in the opposite direction, right? So that's kind of interesting to look at, right? And so we're going to look at an example here, example 4, which is I want to draw a vector diagram of 3x and negative 3/4 y. Okay, so again, I'm going to use my dashed lines, and I find out that k right here is, or x right here, if I write it, is 4 dashes, right? So now, if I'm looking at 3 of them, I'm going to draw my dashed lines. It's going to be 1, 2, 3, 4. That's 1. 1, 2, 3. That's 2. All right, that right there is going to be 3k, or 3x, excuse me. Okay. Then I'm going to subtract 3/4 y, right? Or think of it this way: 3x plus negative 3/4 y. So now, if y is going in this direction right here, okay, I'll go to my dashes, right? And that's going to be 1, 2, 3, 4, 5, 6, 7. 7 dash marks. 3/4 of 7, okay, is going to be something a little bit different. Okay, and so what ends up happening is I'm going to go in an opposite direction. So it's going to flip the direction. So now I'm going this way, right? And 3/4 of it is going to be like this. And so I actually go like this. 3/4 of it is 1, we'll say 5 tick marks. So it's 5, right? And the opposite, right? So this is going to be, let's see, negative 3/4 y. And so our resultant vector is going to be this right here, okay? And so this right here, if I was going to take this and just even move it, right, this is our resulting vector. And so we call this 3x minus 3/4 y, okay? And again, that might seem kind of goofy that you're like, okay, so my answer is just a dotted line, right? Well, the fact of the matter is that is our resultant vector. And right now we're just looking at vectors as specific things. But eventually when we start looking at them as wind speeds and all that kind of stuff, it'll make a little bit more sense, right? Okay, so here's a couple that you could try on your own. Okay, A minus C plus 2B might be interesting for you to try. All right, now, using it in navigation problems, and this is more or less how you're going to see it. It says an airplane is flying with an airspeed of 310 knots, heading 50 degrees, true bearing from north. If a 78 knot wind is blowing, heading in a true heading of 125 degrees, determine the speed and direction of the plane relative to the ground. Okay, again, all we're doing is looking at this as measurements. So let's draw what it looks like. Okay, so my dotted line for my airplane, let's see, 50 degrees. So if this is 45 straight across, right, this is going to be 50, a little bit less than that. I need 310, so I'll say 14, 15 and a half, right? So that's 15 and a half. Okay, I'm going to say that this is, so 1 dash is equal to, let's see, 15 and a half would be, so it's going to be 20. So 1 dash is equal to 20 knots, right? All right, now it says that there's a wind speed, okay? Wind speed going 125 degrees. All right, so if we think about looking back at this, okay, so all the way straight down is 180, right? 125 degrees is going to be, so this would be 90 degrees, right? So 125 would be more like this, right? And so, and it's 78 knots. So I would want, so this would be 60, that would be 80. So it's going to be just a little bit less than that right there, and that's 125. Okay, so that's our wind. So this is our airplane right here. Airplane, and this is our wind. And so our resultant vector is actually going to be this guy right here. Okay, and so let's figure out what that is. Okay? Again, eventually we're going to be able to use our angles, right? And right now we're not looking at that right now, but what we're going to be doing is, I see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 dashes. So 18 times 20 would be 360 knots. And you'll notice that, again, this was 50, right? And so this is just a little bit more than that. And so we'll, if we look at this, we can kind of, again, guess what that's going to be. We'll let that be, let's say that that's 15 from here. So that would be 75 degrees. So, 75 degrees. That's how far it is from right here. We're going to call that 75 degrees. Again, there's actually ways we can figure it out, but this is what's going to end up happening. So I'm going 360 knots at 75 degrees from true north. Okay? And here's another guided practice problem that you can kind of try the same way. All right? Good luck on your assignment. Let me know if you have any questions. Again, for your assignment, make sure you're drawing these out and sending me a picture. I just really want to see your work. I want to see you drawing your vectors out as best as that you can.